You're probably asking yourself is, hey, how come you haven't shown me any examples where there's a negative inside of the square root? Well, the reason is we're still building some of our tools to kind of understand what that means. So right now we're going to be looking at is, well, how do I ensure that the stuff underneath the radical stays positive? Well, one way to look at that is, let's determine what its domain. The domain means what are all of the accepted values that don't make the function crash. And to determine that, I know it crashes when 3x plus 12, if it ever becomes less than 0. It can equal 0, but it can't become less than 0. So I'm going to kind of work it, or I'm going to kind of just look at, well, what happens when that's the case? So 3x plus 12, I want to make sure that that never becomes less than 0. So let's find out, where does it become less than 0 at? So I'm going to write an inequality. 3x plus 12 is less than 0. I'm going to solve that. And it looks like that if I use any value of x that's less than -4, my function is negative inside the radical. And that's a useless value. I can only work with positive numbers. And remember, there's lots of different ways we can write that. Interval notation is my favorite. So this is telling me all values less than -4 do not work. And so one way that I can write that is my domain is all values greater than -4. So if all the values I can't use are less than -4, all the values I can use are greater than -4, but also too I could use -4. So interval notation tells me hard bracket or a closed bracket, -4, infinity, and there's my solution set to represent my domain.